Let's take a look at another example on LaGrange error bound. This was a former free response that we see here. And we are given that f of x is equal to sine of 5x plus pi over 4. And we're asked to let p of x be equal to the third degree Taylor polynomial. We'll underline third degree. For f about x equals 0, let's underline x equals 0, making note that this is centered at 0. And even if they did not say use Lagrange error bound, if they asked us to find the error, we would recognize this last expression as Lagrange error bound simply by understanding that f of 1/10 is the actual function value with 1/10 plugged in. P represents the polynomial approximation cut off at the third degree. And the difference between the two, so actual minus polynomial equals error. We have absolute value because we don't really care if it's positive or negative. And we're saying that it's going to be within or less than 1 over 100th, that's going to be the max error. So let's define that as max error. So we'll begin with just conceptually, you don't eventually have to do this, but I want us to see that the third degree polynomial here that they're referring to starts with the first term being f of 0, since the center is 0, and then expand out, go ahead and do so, up to the third degree. So whatever the function might be, its successive derivatives will give us the ability to find what the third degree polynomial is, and if this was used to approximate the function value at 1/10, the question is it a good approximation? If it's less than 1 over 100th, I would say it's pretty good. So we're asked to show that it is less than 1 over 100th. So this is our polynomial. And tied to that is going to be our error. So let me refix that box here. So this is going to be our polynomial. And remember, the error is tied to the next term, which is going to be left over. And I'm going to do this in pink. It would be the fourth derivative. So we'll need to figure out what the fourth derivative is, over 4 factorial, x minus 0 to the fourth power. So this is going to be, over on the far right, how we find our error. Okay, so always tied to the next term that would have been there if we had continued our Taylor series. So the first term that gets left off. Okay, and then all of this again in purple is our approximation. So looking at the pink, it looks like we need to figure out what the fourth derivative is. So my natural assumption is, looking at sine, that derivative is going to be equal to 1. So I do want to do this example because sometimes the fourth derivative isn't quite as simple. So let's go ahead and find the fourth derivative, given that f of x is equal to sine of 5x plus pi over 4. You guys can pause and continue to find the derivative, or just let this go and then check your work as you're going. As you guys are taking the derivative, you'll notice that there will be repetition that occurs whenever we take successive derivatives of sine and cosine. And normally, if the problem contained a function that did not have a baby function inside, that had, so basically chain rule accounts for the fact that each time you take a successive derivative, you're multiplying by 5. And so the constant in front of each one of your derivatives is changing. And so our analysis from before, where we were talking about, well, what would be the maximum error? Although it is 1 when we're dealing with sine and cosine, we have to account for the fact that there was a chain rule that applied. So when I'm looking at my fourth derivative and I'm asking myself, what is the maximum value for this derivative function? And this is the fourth derivative here, and we're trying to make a replacement here. Again, normally if 625 wasn't there, I would say that this will obtain a maximum of 1. But because the constant is there, we're going to say that the maximum is 625. So as I go to fill out my maximum error, I'm going to say my max error must be less than my fourth derivative, which is 625, over 4 factorial. And let's say we don't know what x is for a moment. X minus 0 to the fourth power. Now this x value, on the previous example, we had the x value being the furthest away from an interval that was given. This problem didn't state an interval. However, the center is 0 and our approximation is at 1/10. So it would make sense that we would want to find our error at 1/10, at x equals 1/10. So we're going to plug that in. So our maximum error must be less than 625 over 4 factorial, 0.1 minus 0 to the fourth power. So if we simplify all of that, we get 625 over 240,000, which when you enter into the calculator is indeed less than 1 over 100. So again, you're not finding the actual error. This is the maximum error bound. You're no worse off than this if you were to use that third degree Taylor polynomial to approximate f of x being sine of 5x plus power 4, and basically we're just kind of giving the person a guarantee that it's not going to be any worse than 1 over 100.